today our objective is to understand scientific notation with negative exponents. Understand and write values. Let's change that word to small. Very small numbers using scientific notation and standard notation. And our focus today, obviously, when we're talking about very small numbers, would be negative exponents. So we're going to do a little bit of a problem. Most of you found your large numbers. So again, online, it was super easy to find a ton of very large numbers. And then very small numbers got to be a little bit harder to think about. And most of them that you guys are going to find have something to do with science, one shape or another. So here's an example of one. And we've got a typical human hair, has a diameter that's equal to 0.00. Let me count. 0.0025 meters. Okay, so a hair is, let's see, tenths, hundreds, thousands, 10,000s, 100,000s, 25 millionths of a meter. Okay, a meter is a very large measurement because a meter is like this big, and we're 25 millionths of a meter. Way over there is a human hair, the diameter of it. So that's going across that human hair. Question is, how do I write this in scientific notation? What do you think this answer would be in scientific notation? Kyler.
2.5.
So it takes the same format. It's a decimal number between 1 and 10. It's got a times, it's got a power of 10. And what's the exponent going to be on that one?
-5.
So let's see if he's right. 1, 2, 3, 4, 5. And he got it absolutely right, with the exception of, in this particular case, we do have to add the label of meters on it. Okay, so if you're given a label, you got to give it back. So what would be the tip-off that your exponent has to be negative other than the heading of the homework and the objective for today? Aaron? Okay, we're moving it right to get to where we need it to be. We're trying to make it larger, so that means it must be really, really small. Now, here's the interesting thing. This makes even more sense. What direction would I have to move the decimal point to write it in standard notation if it's a negative exponent? Okay, Jacob?
The left.
It would have to move to the left. And if you think of a number line, here's your 0. These numbers are positive. To the left are the negative numbers. So that negative is telling you move to the left. So you're getting smaller and smaller and smaller and smaller. So that negative exponent makes a lot of sense when you're writing in standard form. Now, another way that I look at it, your number begins with a decimal point. That's an indication you got a very small number, is because it starts with a decimal point. Okay, so you might want to jot a little note. The number will start with, and there's two options, 0 or the decimal point. So if you have a number that starts with a 0 or starts with a decimal point, you know that it's considered a very small number. Okay, Ryan, write what we're writing. So basically, we're doing the same exact stuff as yesterday. We're just going the opposite direction. That's the only difference between positive exponents and negative exponents, is we're just shifting our direction, okay? So we'll recap our steps. So step 1, we're going to move the decimal. Now this time we're moving it right, because we are trying to make the number look larger until you have a value between 1 and 10. Now remember, it can be exactly 1, but it could never be 10. It could be 9.99999, that would work, but it can't be exactly 10. It can only have one digit in front of the decimal. 2, multiply by the power of 10. So multiply by 10. So you're going to actually physically see that multiplication symbol and the 10 after it. And then you're going to count the number of places. The decimal moved. Okay. Now, here comes the tricky part. Because your number started with 0 or a decimal, your exponent will be negative. And again, that means it's a very small number. Okay, so we count the number of places the decimal moved. Because your number started with 0 or a decimal, your exponent will be negative because it's a very small number. So you're going to write the negative number of places the decimal moved as the exponent. So the only big difference between what we did yesterday, Aaron, write it down, and what we're doing today is the sign of the exponent. And that's it. Okay? Now where it's going to get tricky tomorrow is we're going to give you both of them at the same time, and you have to figure out who's positive, who's negative. Okay? That'll be your homework tomorrow, not tonight. Tomorrow is a review of the things that we're doing. Okay? Okay, can you stop? I'm recording this. Yeah. So let's go ahead and do some examples. Let's start with the first set of directions that we had yesterday, which was to write our numbers in scientific notation. And again, part of what I saw people were getting answers wrong yesterday when we were talking about the topic was that people were not willing to kind of draw those little loops underneath the digits. And honestly, that's going to be the easiest way to do your counting, is to actually physically have something to look at. You could do dots or whatever. Okay, so write each number in scientific notation. So we'll start off with this guy. Let's see. So we're going to have 1, 2, 3, 4 zeros, 8, 2, 9. So when I look at a number, I ask myself, what's the first thing I see in this number? 0. What kind of number starts with 0? Very large or very small?
Very small.
Very small. What kind of exponent does a very small get? Negative, okay? Next, let's go ahead and figure out what is going to be our decimal value in this problem. Taylor B, sorry. Okay, where does the decimal point go? So it's 82.9? Okay. Does that meet the criteria of a number between 1 and 10? Okay. So we got to make sure it meets the criteria of being a number between 1 and 10, so 8.29. So let's see. 1, 2, 3, 4. Bam. So then we know we need to write the times 10 piece. And now we're going to add the exponent. So what would be the exponent on this one? A negative and a 5. So think, how many zeros did you see between the decimal and your first number that wasn't a 0?
4.
There were 4. And then how many did it take to get around that one number that wasn't 0? 1. So we had, when it came to the, if we want to help ourselves in a different way, there were 4 zeros plus 1 more digit. And that gave us the 5 that we were looking for the exponent. Okay, so let's try the next one. All right, this one, ooh. So this one has 1, 2, 3, 4, 5, 6 zeros, followed by 3 2. So let's see, that's tens, thousands, or tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 million. So 3,200 millionths. That's pretty darn small. So Sydney, what is going to be the decimal value that I get from this one? Okay, remember my number has to be between 1 and 10. 0.032 is not between 1 and 10. It's actually less than 1. So try again. There you go. 3.2. Oops. 3.2. And now we got to figure out what we're going to write as our exponent on our power of 10. Cameron.
Negative 7.
So let's see if he's right. So 1, 2, 3, 4, 5, 6. Sure enough. And if you think about it, there were 6 zeros plus, that looks like 60, doesn't it?
Yeah.
Let's try that again. There were 6 zeros plus the 1 digit we needed to get around. And so that would give us the 7. Okay? So that's that answer. All right, next problem, I'm going to give it to you a little bit in a context. Blood cells in the human body. Typically, they would have a diameter that's approximately equal to this. So let's see. 1, 2, 3, 4, 5 zeros followed by a 7. And that's labeled in meters. Okay. So David, what would be the decimal that would represent this number in scientific notation?
7.7.
Okay. Would it be 0.7? Is that between 1 and 10?
7.
Okay, so we need to do it after.
Oh.
So 7. Now, could I write it as 7.0? I could, because there's nothing that comes after that 7, but I don't need to. All right, so now we put in the next part. Okay, Kelly, what do you think the exponent's going to be on this number? You say negative 6. Let's see if he's right. 1, 2, 3, 4, 5, 6. Yeah, and if you think about it, we had 5 zeros, plus we needed to get around 1 digit. So there would have been 6. Very good. Okay. Yes. Okay.
Do we have to write like 4 zeros plus 1 digit on our project?
Okay. Are we taking notes or are we doing our homework? Are we taking notes or are we doing our homework? Okay. When we take our notes, we give explanations where things come from. Okay, do we need to give explanations when we're doing our homework? Not unless they ask you to, okay?
Don't
Right.
have to put the M for our meters.
Oh, thank you for catching my mistake. Yes, this answer is not complete until it has the label of meters on it. So that was the big difference between these three, is that the last one had to have a label because it was given a label. All right, so let's go the other direction. I'm going to give you scientific notation, and your job is to write it in standard notation. So the directions here are going to say, write each number in standard notation. And standard notation simply says, I don't want to see the times power of 10. I want that to go away. So let's start with 1.045 times 10 to the negative 6. Now, what direction does the negative tell us to write our number? Or move the decimal? What direction does the negative tell us to move?
Right.
Nope.
Left.
Negative says get smaller. And because that's where the negatives are on a number line. They're to the left, so we're going to head left. Okay? And we're going to head left 6 spots. So what would my answer look like? What would my answer look like? Okay, and this one just gets an answer. There's nothing, just one solid answer. Connor,
0.00000.
how many zeros is that?
5, sorry. 0.00000.
And then,
1045.
okay. All right, so let's see. I'm going to do the math over on the side here. So if I 1.045, and I move it over 1, 2, 3, 4, 5, 6, and then I'm going to fill up all these blanks.
Yes.
That's exactly right. So is there a way that we could come up with a pattern for how we could do this? Okay, Ryan?
Can't you just do you take 1 away from 6 and then just add 5?
Okay, oops, here, let me go to color. So if we have our number, so again, the number isn't negative. The negative just indicates direction, okay?
Oh.
So we have 6 digits we need to move, and we're going to take away 1 because all of our decimals will have 1 digit in front. So it takes me 1 move to get around him. And that would leave me with 5, which would represent the number of zeros. All right, let's see if we can try that one on the next one. Okay, so number 5, let's see, 9.9 times 10 to the negative 5th. Jacob.
What if, like, you had a number and it was like negative, like 5.00069? Like, how would you like write that, like, as like in scientific notation, like, but then like
If it already, okay, if it's going to get written in scientific notation and it has an exponent, then it would already be in scientific notation,
no,
right?
It was like negative. It was like negative, like 5.000 like 34 or something like that. Like, how would you write the negative?
That's just that number itself would be negative. And by the way, I can't write this in scientific notation because it already is a number. So we're just looking at the number component as being between 1 and 10, so it can have only 1 digit in front of the decimal. So let's hold off and let's do another example like that. Let's finish this one and we'll come back to one like this, okay? All right, so we've got, and the reason why you're not going to see negative numbers in scientific notation is because we're talking about measurable things. Measurable things have to be measurable, and if you've looked on any measuring device, there's no negatives on it. Because negative would just indicate a direction. Like if we have a temperature that's negative 12, that means it's below the 0 mark, which is the below 0. So it's down below. If we have in the ocean something was found at negative 350 feet, that means it was just found below sea level. I still can measure that distance in positive, but the negative just indicates where, in relationship to the level of the ocean, was that number found. Positive above the ocean level, negative below the surface of the water. So we will never have a negative number that we'll have to write in scientific notation, because these are all things that can be measured, all things that can be counted, okay? So you can't have negative 5.2 times 10 to the 5th people who committed suicide for the last 3 weeks in all of the United States. And the reason why I bring that one up is because for some reason there was a lot of people looking up those stats. I thought was weird. So you can't have the negative means there would be the absence of people doing it. So that would be like, I guess, people being born, I guess, would be the opposite of somebody committing suicide, would be people being born. That's kind of weird, okay? All right, so look at this one. We've got 9.9 times 10 to the negative 5th. Alex, what do you think the answer would be on this one? So notice that you have a negative exponent. So on your paper, what direction are you going to move the decimal point? Right or left? If you have a negative exponent.
Left.
Okay, how many places are you going to move it? What does the exponent tell you?
5.
Okay, so go do that on your paper and tell me exactly how to write the answer you get. And don't forget, when you move it, if you have blank spots, you got to fill them up with zeros. The rest of you can be writing this down yourselves. All right, tell me what to write.
0.
Yeah, he's Alex.
Um, 9, 9, 0, 0, 0.
Oh, we're going the wrong direction. Remember, we're going to move left.
Okay.
Move left.
0, 0, 0,
Okay, hold on. What? How many zeros?
3,
Okay, then.
9, 9.
Okay, and the decimal point is, where's the decimal point?
Between the first and second 0.
Here?
Yeah.
Okay, so let's test it out. So we've got 9.9. The negative says move left. We're going to move left 1, 2, 3, 4, 5 spots. Okay? Do you agree with your answer, or do you want to change your answer?
I want to change it now.
Okay, so what would you change your answer to?
Add another 0.
So how many zeros?
4.
So, oops, 4 zeros. And then the 9, 9. And where's the decimal point?
Between the...
Okay, look at
Between the
what we
nines.
did here. Look where the decimal point is, where all my loops are. Where do you see the decimal point?
Oh, at the end.
Okay, is this the end of the number?
No, it's the beginning.
Yeah, it's at the very, very beginning, okay? So that's the whole point, is to move that decimal, because when I write it in standard notation of a very small number, the very first thing I'm going to see is either a 0 or the decimal point, okay? Now, how could I change the answer I have, this 0.000099, so that there would be a 0 would be the first thing you would see? What would I need to do? Mark?
Just put a 0 in front of the decimal.
That's what I mean by the first thing you would see would be a 0 or a decimal point. Is that there's no whole numbers on these because they're very, very small. That's what makes them small. They're in the place value that comes after the decimal point, okay? So did that meet our pattern? Let's see, we had 5 was the exponent. We needed to get around 1 digit. Did our number have 4 zeros?
Yeah.
Yes, it did. So that works. Okay. All right. I thought I saw a hand. Sir, Giovanni.
Do you have to put the 0?
No, that's why it's optional. You don't need to put it. That's why I said you could see a 0 or the decimal point would be the first thing. So that's where I'm saying that you might see a 0 in front. All right, last one is going to be another one. I don't like little creatures, especially that get in my house and make a mess and track. So I hate ants more than anything because they're just little pesties. And so this one says this guy actually sat there, took the time, and he measured an ant. And this is what he found out about an ant. He said an ant is 1 times 10 to the negative second meter. How would I rewrite that answer so that it was in standard notation? Ryan?
0.01 meters.
Okay, so let's see if he's right. We can try our little test here. We had 2 as our exponent. We needed to get around the 1 digit. That leaves 1 0 should be in our answer. And that's what we have. And again, we can try it the other way. If I have 1 and I have to move the decimal point twice over, sure enough, I do have 1 blank. So I agree with that answer. The answer is 0.01 meters. Okay, good.